I'm interested in the philosophy of mathematics, and in particular in mathematical proofs. And the thing that interests me about mathematical proofs is the fact that you can learn so much more from a proof than just that the theorem at the end is true. Because very often when you do a proof or you follow a proof, you have to go through far more interesting mathematics than the theorem at the end. A spectacular example of this is the Fermat theorem, which is an interesting little fact about numbers, which you can understand using just mathematics, arithmetic really, that you learned in school. But in order to prove it, you have to go through some very difficult and abstract mathematics, and you have to learn a great deal about parts of mathematics that aren't immediately to do with numbers. So the proof is very much richer than the theorem. And I think that the fact that proofs can be informative in this way is connected, I think, to the idea that you use specific techniques, domain-specific techniques, when you do mathematical proofs. So, for example, with proofs about whole numbers, you might use ideas to do with which numbers do and don't divide others. And this is a bit like science. Makes mathematics a bit like science because in sciences you have different techniques in different areas. For example, measuring the age of stars, there are techniques that are appropriate for stars. There are different techniques for measuring the ages of trees. And this thought leads us to something about the relationship between mathematical proofs and formal logic. Because the thing about formal logic is that it applies to everything. So, take a simple example. If we know that everything of type A is also of type B, and we know that item I is of type A, then we know for sure that item I is of type B. And that works for everything regardless of what A, B and I are, whereas the techniques for measuring the ages of trees only work with trees, and the techniques for measuring the ages of stars only work with stars. So what we're starting to see in some of the philosophical studies of mathematical proof is that some parts of mathematics, some mathematical ideas, some mathematical proofs are more like star age measurement and tree age measurement than they are like formal logic. And that's interesting.